Okay, we saw previously on over here on slide 86 that a primary alkyl halide primarily undergoes substitution. SN2 substitution, and only a minor amount is elimination, because elimination does not favor primary carbons. So now looking at steric hindrance and how steric hindrance of a primary carbon is going to affect whether we have more substitution, SN2 substitution, or more E2 elimination for a primary carbon. So when we have a primary carbon as our beta carbon, or as our alpha carbon, we know that only SN2 is possible because primary carbons do not make stable carbocations. So here we have a primary carbon bonded to bromine, and that is the alpha carbon. Remember, we called that the carbon bonded to the alkyl halide is called the alpha carbon, and then the adjacent carbon is the beta carbon. So if our beta carbon is a tertiary carbon, then the alpha carbon is sterically hindered. And the methoxide, or the strong base, the nucleophile will be hindered for backside attack of the alpha carbon. And so in that case, the major product is the elimination product at 60%, and the minor product is the SN2 substitution product at 40%. And that occurs because of steric hindrance of the alkyl halide, primary carbon. The second type of steric hindrance that can cause elimination to be favored is a sterically hindered nucleophile. So we showed you earlier that if we have a sterically hindered nucleophile, such as terbutoxide, or we also showed you some other sterically hindered nucleophiles, and with 3 ethyl groups bonded to a carbon that's bonded to oxygen, or 2 methyl groups and 1 ethyl group. Those are all sterically hindered oxynucleophiles. And in the case of a sterically hindered nucleophile, the favored product is the elimination product, and the favored product is also the less substituted elimination product. So if it's possible to make both a monosubstituted bond and a disubstituted bond, or a monosubstituted bond and a trisubstituted bond of an alkene, then the monosubstituted bond will be the major product for elimination. We also have to consider secondary alkyl halides. So on our list of nucleophiles, an SN2 reaction favors primary, and E2 reaction favors tertiary, but they both equally favor secondary. So what happens when we have secondary conditions? How do we know when it's going to have an SN2 major product or when it's going to have an E2 major product? And it's going to depend on a few different factors. One of the factors is going to be substitution. A secondary carbon will undergo substitution when there is a weak base, like acetylide ion, which has a conjugate acid of acetic acid, which has a pKa of 5.8. So that's a weak acid, but it's a stronger acid than, for example, an alcohol. So acetylide ion is a weaker base than ethoxide, shown below, which has the conjugate acid of ethanol, which has a pKa of 16. The one with the higher pKa is the stronger base, has the stronger conjugate base. And so the ethoxide is a stronger conjugate base. Okay. The ethoxide is the stronger conjugate base, with the pKa of the conjugate acid being 16, and acetate ion, the deprotonated acetic acid, is the weaker